Today we're going to be talking about the second half of lesson 1.3 for advanced math. So if you're looking at your guided notes at the top, there's some information that you're going to have to fill in the blanks. So for instance, some equations do not have one solution. Equations can also have no solution or infinitely many solutions. So the equations that we've looked at so far might have been something like x equals 16 or t equals 0.5. These types of equations are said to have one solution. There is one correct answer. When we're looking at the equations for today, we're going to have some equations that are not going to have any answers at all, and we're going to have some equations that every number in existence could actually be an answer. So we're going to fill those blanks in with no solution or infinitely many solutions. So when you're looking underneath of that, it's going to ask for some examples. So some examples of no solution might be an answer that said something about 4 equals 9. This would be an example of no solution because we all know that 4 is not the same as 9. So these are not equal. This is a no solution. Another one could be something like 17 equals 1. We know that 17 and 1 are not equal. Another one could be something like 1/2 equals 3/4. We know that these again are not equal. So these are all called no solution. Then we have some that are going to be said to have infinitely many solutions. So when we solve or work out these equations, you might end up with an answer that says something like 3 equals 3. We know that 3 does equal 3. It's always going to be equal and it's never going to change. Another example might be something like if we end up with A equals A. We know that an apple is always going to be equal to another apple. Or something maybe like 0.6 is equal to 0.6. We know that this is true and this is not going to be changing. So these are going to be called infinitely many solutions. And when we get an equation that works out like this is simply just telling us that every number could be an answer to this equation. Go ahead and try to solve numbers 4 through 7 now. Go ahead and come back in a couple minutes and we're going to look at those together. All right, now we're going to go ahead and take a look at numbers 4 through 7 here on this page. So starting with number 4 here, we are going to simply try to solve for the variable. There are several ways that we could do this. The first thing we might want to do is we could subtract 2x from each side. This is a positive 2x, so the opposite would be to subtract 2x. When we're using those inverse operations, we know that 2x minus 2x cancels. So we're left with 1. Again, 2x minus 2x is canceling each other out, and we're left with negative 1. If 1 is not equal to negative 1, which we know it is not, this equation would be said to have no solution. On the next one over here, we're going to take this 1/2. This is the distributive property here. We're going to multiply it by everything inside the parentheses. So here 1/2 times 6t, 1/2 of 6t is 3t. 1/2 of negative 4 is negative 2. So now we have 3t minus negative 2 is equal to 3t minus 2. Here again, we can start by subtracting 3t on each side. 3t minus 3t will cancel. We're left with negative 2 is equal to 3t minus 3t cancels. And again, we're left with negative 2. So here we see that negative 2 is equal to negative 2. So this equation would have infinitely many solutions. Now let's go ahead and take a look at numbers 6 and 7. So here with number 6, we are again going to need to distribute this inside the parentheses. So we can think of these whole numbers as having a 1 underneath of them. 1 times 2b is 2b. 3 times 1 is 3. So 1/3 times 2b is 2/3 b. 1/3 of 9 would be 3. Or you could have 1 times 9 is 9. 3 times 1 is 3. And 9 over 3 again is equal to 3. Here we again need to distribute. 2/3 times b is 2/3 b. 2/3 times 9/2. 2 times 9 is 18. And 3 times 2 is 6. 18 divided by 6 is 3. So again, we're going to start here by subtracting 2/3 b from each side. 2/3 b, take away 2/3 b will cancel. We are left with 3. 2/3 b, take away 2/3 b again is 3. Again, we know that 3 is always equal to 3. So again, we have infinitely many solutions here. This just means that every number put in for the variable is always going to make the equation true. Now in this last one, again, we need to distribute into the parentheses. 6 times 5 is 30. 6 times negative 2v. 6 times 2 is 12. Positive times a negative is a negative. Again, here we're going to distribute. Negative 4 times 3 is negative 12v. Negative 4 times positive 1 is negative 4. So here I'm going to start by adding 12v to both sides. And again, there's several different ways you can do this. And as long as you're using your inverse operations correctly, you should come up with the same answer, no matter which method you start with. So here, negative 12v plus 12v will cancel. We're left with 30. Negative 12v plus 12v, again, will cancel, and we're left with negative 4. We should know that 30 does not equal negative 4, so this equation will be no solution. There is no value that would ever make this equation true. Now, go ahead and turn the page on your guided notes. Example 5 here is telling you that these two circles are identical, and it's wanting the area of each circle. So if we look at the first one, they are giving us the radius. Halfway across from the center point to the outside, halfway is the radius. The second circle is giving us the diameter. All the way across, crossing through the middle point, is the diameter. So if we recall from previous years, to find the area of a circle, we have area equals pi r squared. So pi times the radius squared. In the first circle, we know that the radius is equal to x plus 2. And in the second circle, it tells us that the diameter is 4x. So here we know that half of 4x, if we divide this by 2 to get the radius, cut it in half, we are going to get 2x. In the directions, it's telling us that they are identical. So what this is telling us is that we know that if the circles are identical, their radius of each has to also be identical. So x plus 2 is equal to 2x, and we are going to solve for this. So subtract x from both sides. X take away x cancels, and we're left with 2. 2x take away x. This is like saying 2 apples take away an apple, you're left with 1 apple. So here we have x equals 2. So if x equals 2, what is the radius? So if the radius is x plus 2 and x is equal to 2, 2 plus 2 is equal to 4. So the radius of each circle is 4. Now, in order to find the area, again, we're going to plug this information in. So area is equal to pi r squared. We have the radius of 4. We should know that 4 squared is like 4 times 4. 4 times 4 is 16. So we could say that the area of this is 16 pi. You could also multiply 16 by 3.14 if it's asking you to work it out and have an exact answer. Most often it's going to ask you in terms of pi. So it's just wanting an answer like this, 16 pi. Now, if we go ahead and take a look at example 6, it says a boat travels X miles per hour upstream on the Mississippi River. On the return trip, the boat travels 2 miles per hour faster. How far does the boat travel upstream? So we know that if the boat's traveling upstream and then back downstream, that this is the same distance. The distance between the top and the bottom of the stream are not changing from the one travel to the next. So we know that on the way upstream, it takes 3 hours. So this is going to be our variable x. On the way back, it's taking 2.5 hours. And we know that they traveled 2 miles an hour faster. So x plus 2. In order to find the distance, we are going to write an equation. So 3x is equal to 2.5 x plus 2. So here we're going to start by distributing. 2.5x is 2.5x. 2.5 times 2 is 5. So here we have 3x equals 2.5x plus 5. Subtract 2.5x from both sides. Keep in mind that when you're adding and subtracting decimals, you need to line them up. So this is like saying $3, take away $2.50 would be 50 cents or 0.5x. I know that we're not talking about money in this example, but often when we're dealing with decimals, it helps us to think of it that way. This side will cancel out and we'll be left with 5. Here, the opposite of multiplying by 0.5 would be to divide by 0.5 on each side. This will cancel, we'll be left with x. 5 divided by 0.5. Here we need to take this decimal out. Take this one out. You can add a 0 for a placeholder. 5 goes into 5 one time. Bring down our 0, and 5 can go into 0 0 times. So here we know that our distance, our x, is 10 miles. Now we're going to take a look at number 8. In number 8, it says, what if in example 5, the diameter of the purple circle is 3x? What is the area of each circle? So here we would have the radius being, if the diameter is 3x, the radius would be 1.5x. So we know that the two radius are going to be equal to each other again. So 1.5x equals x plus 2. Again, we can subtract x from both sides. So 1.5, remember the coefficient in front, if there's not one, is always a 1. It's called the imaginary 1. So 1.5x minus 1x is 0.5x is equal to 2. Divide by 0.5 on both sides. We're left with x equals 2 divided by 0.5. Again, move that decimal point out. 5 can go into 24 times. So x would be 4. So again, when we go to plug this in, if our area is equal to pi r squared, our x is 4, we know that our radius is 4 plus 2, which is 4 plus 2, giving you the answer early, which is 6. So here we have pi times 6 squared. And we know that 6 squared is 36. So here we have 36 pi. Now on the last one here, we have number 9. Number 9 says a boat travels X miles per hour from one island to another island in 2.5 hours. So if we're traveling from island A to island B, we are going X miles in 2.5 hours. The boat travels 5 miles per hour faster on the return trip of 2 hours. So we have 2 hours, the same number of miles, plus 5 miles faster. What is the distance between the islands? So again, we know that when we go from one to the other and then back, that the distance between them is not changing. So we can set these two things equal to each other again. So 2.5x is equal to 2 times the quantity of x plus 5. Distribute this inside the parentheses here. 2 times x is 2x. 2 times 5 is 10. Subtract 2x from both sides. Again, make sure that you're lining up your decimals. 2.5 minus 2 is 0.5x equals 10. Again, we can divide by 0.5 on both sides. 10 divided by 0.5 is 50. So the distance between those two islands would be 50 miles.